অ্যাসিস্ট্যান্ট প্রফেসর হিসেবে কর্মরত। তাছাড়া বর্তমানে উনি ইনস্টিটিউশনাল কোয়ালিটি অ্যাসুরেন্সের বুয়েটের এডিশনাল ডিরেক্টর। ডক্টর কাজী বাজিদ কবির 2004 সালে বুয়েট থেকে বিএসসি ইন কেমিক্যাল ইঞ্জিনিয়ারিং পাশ করেন। এমএসসি ইন কেমিক্যাল ইঞ্জিনিয়ারিং পাশ করেন 2009 সালে বুয়েট থেকে। পিএইচডি লাভ করে 2014 সালে মনাশ ইউনিভার্সিটি অস্ট্রেলিয়া থেকে। তার পিএইচডি এর বিষয় ছিল প্রডিউস মিথাইল ইথার ফ্রম কোল, এনার্জি, এনভায়রনমেন্ট এবং রিঅ্যাকশন ইঞ্জিনিয়ারিং। এ ডক্টর বাজিদ কবিরের প্রবল আগ্রহ এবং এ সকল ফিল্ডে উনি প্রচুর কাজ করেছেন। তার প্রিয় বিষয় এনভায়রনমেন্ট এবং কোল পাওয়ার। আজকে উনি তার প্রিয় বিষয়ের উপরই কিনোট প্রেজেন্ট করবেন, এনভায়রনমেন্টাল অ্যান্ড সোশ্যাল ইম্প্যাক্ট অফ কোল ফায়ার্ড পাওয়ার প্ল্যান্ট। আমি অনুরোধ করছি ডক্টর বাজিদ কবিরকে তার কিনোট প্রেজেন্ট করার জন্য। ডক্টর কাজী বাজিদ কবির।
Thank you, Engineer A.N.M. Tariq Abdullah, for kind introduction. Honorable Chief Guest, Engineer Muslim Famino, and the Honorable Minister, Ministry of Information, Government of the People's Republic of Bangladesh. The special guest engineer M. Kobir Ahmed Bia, President IEB, Engineer MD Abdul Sabur, HTS IEB, Chairman of the Program Engineer MD Mosaddek Hossain, Chairman Chemical Engineering Division IEB, and distinguished guests. A good evening to you all. I'm feeling very privileged to be here to deliver my second keynote speech. So I'm actually back. I delivered another one last year, so it's going to be 2 in a row. And today I'm going to talk about environmental and social effects of coal-fired power plants. When I selected this topic for this presentation, I was actually in a dilemma. So should I or should I not talk about this topic? This is a topic very close to my work, but the thing is, when I read newspapers, every now and then I find few articles here and there describing about the environmental effects of coal-fired power plants, how these plants are bad and polluting the country, things like that. The thing is, I feel like everyone is an expert on the topic. So should I or should I not talk about it? I was looking into a painting yesterday. It was about something. It was something to do with the Ramphal power plant, and in that one, on the left corner, I found something very amusing. It looks like a cooling tower, but it has black smokes coming out from it. I have been to many power plants, coal-fired power plants in US and in Australia. I haven't seen a cooling tower which has black smoke coming out of it. So maybe the artist is very imaginative, and maybe I'm not. I'm an engineer. I deal with facts. So I'll try to share what I know a little bit about coal-fired power plants. Maybe we cannot match with the imaginative picture, but it will definitely deliver the facts. So with this slide, I'm actually going back in time. This is an article from the Time magazine, and it's from 2005. I was actually sitting in the teachers club at Buet, and I was just skimming through this magazine, and I found this article that day. And I was thinking, what is this statement? Coal is back. I was not interested about coal at that time. But somehow this title got stuck into my head. And later on, when I started working with coal, I realized at that particular time, in October 2005, that the price of Brent crude oil was $70 plus, when the price for Newcastle coal was roughly $45 per metric ton. So, if we see the comparison, that time the crude oil price was going up, and coal was the most viable option as an energy source. So that's why the article was there about coal coming back. Now, let's see what happened in last 40 odd years. So in this figure, I have a comparison between energy mix in 1973 and 2013. And in the 1973 one, I can see that the coal had 24.5% share, where in 2013 it went up to roughly 29%. So coal actually had a very good time in these 40 years. And it's still gaining momentum. So let's see what will happen in future. This is a prediction made by IEA for next 26 years. So by 2040, the coal consumption will go up by 800 billion tons, just because of India. India will be the major consumer of coal, and all the developing countries will also use coal, but the developed countries will try to reduce their coal consumption because they are concerned about environment and other things. But overall, coal will grow at a lower rate, but it will still grow. If we look at the Bangladesh scenario, we have 6 coal mines and a probable reserve of 3.3 billion tons, out of which with current technology we'll be able to extract 1.2 billion tons. We have mining operation in 1 coal mine, and we have extracted roughly 7.6 million tons out of that, the 64 million tons recoverable. And according to our power sector roadmap, we'll have 19,000 megawatts of electricity by 2030 from coal. That's a huge quantity of coal. And if we look at the reserve and consumption ratio, definitely we'll need imported coal. So we'll not only use our high quality coal, we have to import coal from other countries. Maybe I'll skip some of the technical slides. I'll come to this typical layout of the pulverized coal-fired power plant. Here we can see that we have the coal preparation section, where we have the coal pile, which will go through the pulverizer to the boiler, and the heat coming out of the boiler will go to steam, which will turn the turbine, and from the coal we'll get the combustion byproduct, which is flue gas, which will pass through few setups to reduce its impact on environment, and eventually it will go to the environment through the state. So, while talking about use of coal, we should also consider efficiency. The reason is, if we can burn coal efficiently, we'll be able to produce 1 unit of energy from less coal. So we'll need to burn less. And to do that, by doing that, we'll be able to reduce our CO2 emission. And this efficiency and emission curve not only dependent on the technology we'll be using, it also depends on the type of coal. The type of coal actually is a major factor when we are considering efficiency and emission. Higher moisture or higher sulfur or higher ash definitely going to produce more polluting gas and less efficient power plants. So in the combustion reaction, we basically have carbon and hydrogen reacting with oxygen, and we produce a huge array of products, out of which we can avoid most of that, but we cannot avoid CO2 and water. And for coal, we cannot avoid ash. So what we can do, we can actually reduce the amount of CO2 and water by increasing the efficiency of power generation, so that we can burn less coal. Okay, now coming to the environmental impact. When we burn coal, we get some combustion byproducts. These are solid byproducts. These are in the forms of either fly ash or bottom ash. It can be boiler slag or FGD residue. These coal combustion byproducts usually contain elements that are not harmful, but sometimes they can have some trace elements like arsenic, barium, beryllium, etc. So if we look into the potential hazards and contamination pathways for the CCBs, which are solid residues from coal combustion, major ways can be soil contamination and water contamination. And if we don't take it seriously, it can end up in our food chain. And now moving on to the gaseous emissions, we have oxides of sulfur, carbon dioxide, nitrogen. We also have organic and inorganic fine particles. So oxides of sulfur can actually cause acid rain. So can oxides of nitrogen. Nitrogen oxides can also take part in photochemical reactions and reduce visibility. So, moving on to fine particulate matters. Actually, we have a wide range of mineral matters in coal. So, when coal starts to combust, some of these mineral matters will actually volatilize, as they are an integral part of the organometallic structure. And some of them will be retained in the char structure, which will then release after the oxidation of char. And these fine particulate matters will come out as fly ash, and the more coarser particulate matters will come as the bottom ash. And if we look into the health impacts of particulate matters, it can actually cause diseases related to heart and lung, so not very good. But if we can contain the PM, most of this can be avoided. Another polluting agent that can come out of coal is organic carbon, which is a result of incomplete combustion. This is a photograph of Borofpuria power plant taken by myself. So one of the chimney was running at steady state, and the other one was at startup. So basically, this organic carbon will come out only when the combustion starts. And during steady state run, we'll never see this black smoke coming out. And that's why organic carbon is not a big issue when dealing with coal-fired power plants. Like organic matter, carbon monoxide is also a product of incomplete combustion. It can be very harmful. I have worked with carbon monoxide for 4 years, so I know carbon monoxide very well. But when a coal-fired power plant is running at steady state, we'll almost have no CO. So it's again not a problem for the power production process. Now, coming to the trace elements, there are many trace elements in coal, some of which are relatively less volatile, some are moderately volatile, and some are really volatile. So what happens during combustion? The non-volatile trace elements actually distributes equally between the fly ash and the bottom ash. The moderate volatile ones vaporizes in the boiler, but it condenses later when it comes out of the boiler. So we get more of these moderate volatile ones in the fly ash than the bottom ash. And there are some elements which will actually stay in the vapor phase and come out as a vapor. So it's like mercury, it will come out in the vapor stream. So these were all the environmental impacts. I just talked about the environmental impact. I didn't actually tell you guys what will happen if we can contain all this. So now moving on to the economic impact of coal-fired power plants. First of all, it will be a big positive on our GDP. It will create jobs. It will also result in direct and induced job. It might cause some unemployment in the locality for a short time, but eventually it will create more jobs than it took away. How can it change the quality of life? We'll have access to electricity, which will be an impact on local and national level. We can have, the locality can have better access to drinking water. And definitely a coal-fired power plant will help on infrastructure development because they'll need roads and railways. And definitely electrification in the locality as well as nationwide. And it might have an impact on education and literacy because they might have better schooling within the power plant facility, which will actually enhance the education system in the vicinity of the power plant. And another positive we might have from power plants is improvement in healthcare affordability for the local people and improvement in hospital systems in the local area. So let's talk about one such power plant. This is a 1320 megawatt coal-based power plant, which is a proposed power plant, will be located at Rampal. And if we look at, so everyone is concerned about the pollution, and I actually talked about all the pollution and polluting gases. I haven't said any positive thing. So let's look at the picture. What will happen when Rampal power plant actually goes into operation? So, sulfur dioxide or oxides of sulfur, the background concentration is 9.1. If they just emit all the flue gases without any treatment, they will add 51 microgram per meter cube, but they will have an FGD, which is flue gas desulfurization unit. And that will add only 5.1 microgram per meter cube to the background. And if we look into the ECR 1997, the recommended level of SOx is 80 microgram per meter cube. So, which is way above the SOx emission or SOx concentration in the vicinity. And if we are really concerned about Sundarban, let's see what is the SOx, what will be the SOx concentration at the tip of Sundarban, which is like roughly 14 kilometers away from the power plant. It will be 9.86 when we have background SOx of 9.1. So I actually can't realize how can this harm Sundarban. If we look into the facts, I can see it happening. If we look into the NOx concentration, the background is 18 and it will add 30.54. If they have SCR, which is selective catalytic reactor, they will reduce 23.9 out of that 30.54. So, sorry, they will make it 18 plus 4. So they'll remove roughly 26 microgram per meter cube of that NOx. And at the tip of Sundarban, without using SCR, they'll have 24 microgram per meter cube NOx concentration. So they didn't consider SCR at that time, but they might. The suggestion was to use SCR. And if we look at the ECR recommendation, it's 100 microgram per meter cube. Still, if we compare these two numbers, NOx concentration in the atmosphere is quite low compared to what is recommended. And the social responsibilities of that Rampal power plant, as they have stated. Let me please read out this. Improvement of water supply and sanitation. Regional electricity supply. Establishment and development of educational institutions. Initiation of educational scholarships. Improvement of health and Medicare facilities. Development of culture and sports facilities. Skill or capacity build-up training program for the local people. Overall livelihood development, improvements of the quality of lifestyle. So if I look into the facts about the emission, and if I also look at the social responsibility they will take, I don't see any harm caused by that Rampal power plant. Let's look at another picture. I took it from one of the newspapers, the Bashkhali coal-based power plant, which is also a proposed one. And in this photograph, you can see it only says SAL. It's broken because you all know something happened there. And the only reason is people actually don't know. They don't know much about coal-fired power plants. And if someone just pokes them around and say, okay, this coal-fired power plant is going to kill you all, it's very easy to agitate a community with poverty and many other problems. So I don't know what actually happened there, but maybe they didn't convey how they are going to run their coal-fired power plant, what will be their social responsibility, how they will take care of the community. Because if we just think about that power plant will be there, and the people operating the power plant will be also there. They are not going to kill themselves. So basically, if they had a better communication with the community, maybe this could be avoided. Now, I'm going to talk about some misconceptions, like the SLM one. So here, I just found it this month in the Chemical Engineer magazine published by iChemy. And here you can see they have deaths from Fukushima incident. From tsunami, 20,000. In the evacuation or from stress resulting from it, 1,500. From radiation, it's 0. And we all know what happened afterwards. Germany decided to stop all their nuclear-fired power plants. So it's, I don't know how to describe this. If they look into the fact, nothing happened there. So no harm done. And if we look at the radiation values, till date it's only 1 millisievert, which is less than a whole body CT scan. So how can radiation kill the people if there is no radiation there? And here it says estimated average total lifetime dose for Fukushima resident without site remediation. So without doing anything, it will be only 10 millisievert. And I see these kind of articles every now and then. It's coal-fired power plants versus renewable energy all the time. Like we'll just grow energy on trees, something like that, and we'll be able to shut down all the coal-fired, not only coal-fired, all the gas-fired, all the HFO-fired power plants. And we'll just have renewable energy, 100%. I don't know how that will happen. If someone says something like this, probably he doesn't know how electricity is generated, how we have to dig out the primary energy sources and how we have to convert that to usable form. They will definitely want the electricity, but they are actually in a dream. They are thinking we can do it without combustion. I have to ask one question to them. How will they run their cars? Will not they combust something? Maybe the batteries will do that for them. But to charge that battery, they need electricity. So how to educate the community or locality? Best way to deal with it is to let them know the worst case scenario. Like, okay, you are going to die, you are going to die, you are going to die, and you are going to die. Then, what we have to do, we have to assure that the technology is mature enough to take care of them and all of us. And I personally think engineers can deliver that message, especially as I'm a chemical engineer, I would say, especially chemical engineers, because we know material and energy balance, we deal with process, we deal with safety, we deal with all kinds of dirty stuff. We know how we have layers of safety features in a process plant. So I think we are the best person to deliver that message. And I have something in relation to this to say. Like in our country, we don't have chemical engineers in the power sector. Very few. Like chemical engineers and power production doesn't match at all. How come? Chemical engineers are producing electricity all over the world, and I think they can deal with it better than others. So how to control or reduce emission? So the number one tool we have is our national guideline. That will actually decide how we are going to run our plant. If we say, okay, we don't have any emission guideline, everyone will just start their power plant and they will do whatever they want to. But if we have a guideline, which we have, and if we implement that, if the power producers implement that properly, we'll definitely have a safe environment. And to deal with coal, we have mature technologies like ESP, SCR, FGD. So we can actually capture NOx, SOx, particulate matter, and mercury. And let's look into, as we are engineers, we are interested in the process economics. If we look into the pie chart of the costs, ESP will take only 2% of the operating and maintenance cost. FGD will take the maximum, which is roughly 10%, and SCR roughly 6%. And it's not much if we compare with the overall maintenance cost. Maybe the industrialists will not agree with me, but as an engineer, I'll say this is not much. We have to save our environment, and if we compare our environment and this cost is nothing. So we'll have to have all these things in our power plants. And if we look into the national guideline, unfortunately, we don't have anything for coal-fired power plants yet. But I actually had the opportunity to look into the new ECR, which will probably come into effect later. They actually have differentiated between coal-fired, gas-fired, and HFO-fired power plants. So they will have different guidelines for all these things. And this is the ambient air quality, which I have already talked about during the Rampal comparison. And so we have these guidelines, and if we follow them, no way Sundarban is going to destroy, we are going to destroy Sundarban just by building a power plant next to it. Like they don't have anything else going on in Sundarban. Actually, I don't know the actual numbers of brick kilns next to Sundarban. Maybe they have many. I don't know. So they also burn coal, and no one is talking about that. So what about the future? How can we take coal and look forward? So I have few concepts here. One of these concepts is the power factory concept. And basically, this concept tells us not to isolate the power plants. The power plant will be a part of the community. And if you look in here, it says social license to operate. So you are dealing with the community, you are talking to them, you are assuring them that you have all the safeguards and no harm done. And what will happen, the power plant will actually get benefited. So they will have all other economic activities, like all the waste generated, like CCB, the combustion byproducts, can be used either in cement manufacturing or in brick manufacturing. These are all mature technologies. This can be done. And if they are just next to the community, it's easy access to everything. And looking into the future, we can also have things like CO2 sequestration by using algae ponds, which will actually produce more energy. So algae can be used to produce biodiesel. And that can be used for many other industrial applications. Here on the right top, we can see we have a box where it says biomass, municipal solid waste, industrial waste, low quality coal, and co-firing fuels. So basically, if we have such a coal power plant in the community, we can use other fuels with coal. So we can actually mix, which is a known concept, co-firing. So they're doing it in US. So they feed 5% or 10% of the total fuel in the form of biomass. And the right way to do it is integrate across boundary. So not necessarily we'll have only coal, we'll mix it with renewables, and biomass is going to be one of the key factors when we'll be dealing with coal. And maybe one day we'll be able to replace all the coal with biomass-fired power plants. It's a possibility. Nowadays, they don't use more than 10% biomass in a coal-fired power plants. Maybe it will go up, and it can take over the coal-fired power plants. Biomass is a renewable energy source. So who can complain about biomass? But still, there will be combustion, there will be same effect. If we have proper safeguards, we can do it. Definitely we can do it. And another concept is polygeneration. I have a I have a print typo here. It's polygeneration. So here, what happens in this plant, in this type of plant, it's not only electricity they are producing. They can produce a wide array of products based on their configuration. And a positive thing about polygeneration system is it can actually produce crude oil-like products. So if we have Fischer-Tropsch with power generation, it can produce sulfur-free diesel, petrol, jet fuel, everything we need. The technology is there from 1920s. So it's only the economics of the process that's currently not enabling us to use this kind of processes, but maybe when we'll run out of all the other sources, we'll have to go for this kind of processes. Now, I like these two simple equations. One is energy now equals to combustion, energy tomorrow equals to combustion. And I believe it, there's no doubt about it. Renewable energy will replace combustion, but it will take a very, very long time. And it will be only a part of the energy produced by combustion, not all of it. And definitely in next 50 years, combustion will remain the first choice of energy. And if we look into what we have, coal is going to be, or combustion of coal is going to be definitely our way to do it. And I also like this picture. This is about energy security. So for energy security, we need accessible supply, reliable supply, and affordable supply at a reasonable cost. These three combines into energy security. And at this moment, coal is the most viable option for us. But we have to be careful. As I said, the coal property can actually change the process performance quite a lot. We have good quality coal in the country, but when we are importing the coal, we have to make sure we have the proper one. We have to look into the volatile content, heating value, and ash content, and how much trace elements we have, like mercury and other polluting trace elements, how much we have in that coal. And one more thing is the right process to use that coal. So these two are very essential. If we can do that, we'll never do harm to our environment. Thank you very much.
ধন্যবাদ ডক্টর কাজী বাইজিদ কলি। এখন কিনোট প্রেজেন্টেশনের উপর ডিসকাশন পর্বে আমি ডক্টর রফিকুল ইসলাম ডিন, ইঞ্জিনিয়ারিং অনুষদ।